In this task we'll see yet one more example of how playing with arrays and accessing array elements can be used, and how something like that can be done in different ways. So the idea in here is that we would like to write a code which will check whether a given array is a palindrome. For those of you maybe who don't remember, a palindrome is such, for instance, when we talk about words, it's such a word that read forward and backward gives the same word. For instance, radar is such an example. And then here as an array, so we could also think about just numeric arrays, like having a vector. So if that vector has elements read forward and backward, making the same vector, that it means it's a palindrome. For instance, if I wanted to set a vector 9, 2, 10, 2, and 9 again, this is a palindrome. And for instance, if I have 9, 2, 10, 3, and 9, this is not anymore a palindrome because this pair is not matching. Alright, so this can be done in MATLAB with and without loops. For your benefit, I'll show both techniques. So let's start with the one using loops. And what does it mean? How can we check that a given array is a palindrome? Well, we'd like to visit specific elements of that array and keep comparing them with the respective element on the other side. So for instance, if I look at element 1 in here, I would like to verify that it is actually equal to the last one. If I take second element, I would compare it with second last, and so on, until we reach the center of the array. Now, if the array has even number of elements, so like 4, 6, 8, and so on, then there would be actually one more element to be compared with, and if the number of elements is odd, like in here we have this one central element, then this one we just compare with itself, which basically means that one will always be true, that is the same. And so how can we now relate, how can we use a loop? Of course we could do it manually and then do many comparisons, but that's not the point, because our array can be very long and it's just not practical to adjust your code every time how many comparisons. Like in this case there would be at least 2 comparisons to be done. If our array has 100 elements, there would have to be 50 comparisons. You don't want to do it manually in 50 steps. But that's what loops are for. And so we will need to tell our loop to do some indexing which will benefit us. So we need to visit half of the array. So it would mean that it at least needs to do as many steps as from 1 up to half of the length of our vector. If n determines how many elements we have, then we have to go up to half. Again, if the number of elements is odd, like 5, this can't be 2.5, or actually it can just remain 2.5. It's okay, because MATLAB will stop on 2 and it will not go to 3. And what we want to do, if I call this index I, so I will be 1, and then I will be 2, and for this case it will stop there. Now for I equal 1, I want to compare this first element with the last one. So last one, we can represent it as end. Now second last, so to be compared with the second element, would be n minus 1. Now if we had a longer array, then the third one would be compared with n minus 2, and so on. So now when I know that the start, the left-hand side, goes just by index I, 1, 2, 3, and so on, I would like to relate those ones with I, because now you see something is changing, but it's in a relatively regular way. In here it's as if we have minus 0. So if we went on, there would be end minus 3, and so on. So you see there's always minus something, always changing by 1, and that something is actually related with our I, because that something is always smaller by 1. So what we can do is represent this, for instance, as end minus a number which is smaller by 1 from our I index. So I minus 1, like that. If we get rid of brackets, it's the same as end minus I and plus 1. Whichever way speaks to you better, you can use that one. So this is actually that pair that we will need, this one and I, for the pairwise comparisons. So now let's jump into the code and actually do the job in MATLAB. I'll define the array, and I'll use first the palindrome case. And now we said we will need a for loop where I will be going from 1 to half of the length of our word. I don't want to write length every time, so I'll find that once in here. And now what is happening, we will be looking at the ith element of x and compare it with that one which is end minus I plus 1. Now this is just a skeleton of the code, because now we have to build what comes around it. So what does it actually mean that we keep checking and then have the final result? Normally, if these two are equal, then it's fine with us. So we can, for instance, from the start, we can assume that an array is a palindrome, and only when we find a non-matching pair, then we switch that information and then we stop looking. So I suggest creating a flag. This kind of variable is called a flag, which is true or false. You give it an initial value based on the way you write the code, and then you swap it when some condition is met. So as I said, I will first just assume that my given vector, my given array is a palindrome. So I just set the flag to true. You can also use just numeric 0, 1. That's perfectly fine. And now what happens in here? So I will say that if this is true, my flag should remain true. But this is something that is already the case, so I don't have to keep kind of ensuring MATLAB that yes, keep it true. I would rather change this condition in here to the opposite. And then I will say that if I find such a pair of I and n minus I plus 1, that they are not equal, so it's true that they are not equal, then I will change my flag into false. Because this is the point where when I find at least one non-matching pair, that's it. And there is nothing else in this loop that would put this flag back to true. Once it's changed to false, it will stay there. And then once we have it figured out, we can just make our displaying and conditional now on what f is. So if f is true, I will display the array is a palindrome, and else, so notice that I don't say else f is false. No, I just say else because MATLAB will know that opposite from true, the only thing left is false. So then I just display the array is not a palindrome. Okay, so this should do the job. Let's run it. So now for this array I gave, we should just see that this is a palindrome, and that's true, and now I'll modify it, and this is not a palindrome. So that's one way to go. One comment here, still in this case our loop, even if it finds a non-matching pair, like in here already the second pair is the one which kills the palindrome condition, even though we find somewhere, it will keep checking until half of the word. So if you want to save computational time, you can stop that checking once this has happened, and that's where command break comes in. So this break actually means that it will stop the closest loop that it is in. So in this case, this only loop that we have. Alright, then this was the loop solution. We could also do solution without a loop. And for that, now how would we understand it? We would like to compare our array with its flipped version. So what I mean by flip, I mean that we would be looking at the one read from the other side. So 9, 9, 0, 2, 0, and 9. So I would like MATLAB to compare the original array with the one which is flipped. Now the flipping we could do in a loop, but that wouldn't be very smart if we want to avoid loops at all. But we can ask MATLAB if there is something for flipping arrays. And I already know there is, but you could make the search yourself. So when I type flip array, in help I get few hits, and the first three are the most commonly in use. So there is general flip, where it says the order of elements is reversed, and then we have flip LR and UD. So these two are actually, if we want to flip in a matrix, you want to flip, for instance, left right flips columns. So instead of reading the array from first column till the last, it will kind of reverse the order. So first we will see the last column and so on. And then up down flips rows of a matrix. Now we have just a vector, so basic flip is just fine. And let me demonstrate for you how it works. We have our array here, and if I say flip x, we will see the one I just typed a while ago as the flipped one. So that means that we will be only left with if else, and we want to compare whether x equals its own flipped version. And now if this is true, the array is palindrome, and otherwise it's not. Before we can say that this is okay, we should make sure we understand what is actually happening when we do something like that, flip, like a comparison of x equals flip x. So x and flipped x are equally long, and that's the first condition why this kind of comparison is actually allowed, because we have equally long two arrays, and such a comparison means MATLAB looks at pairwise elements. If I combine here in one array x and flipped x, so you see that logical output compares, are these two equal? Yes. Are these two equal? No. These two, no, 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 and yes. So that's where the ones and zeros come from. Now if we have a palindrome, it means that we should have all ones in here. And now you have to be aware that this condition in here, so this brings a bunch of zeros and ones for MATLAB. And how if reacts is that if it has a bunch of logical outputs, it basically puts the logical AND in between. So now that means that that one will only be true if all of them are ones. So you can only say if you have true and false, for instance, true and then maybe one more true, this will return false because at least one of them is not right. So you see it returns logical 0. But if I had all of them true, then I get logical 1. And that means for us that it really works in this case, that if we have a palindrome, which means all the pairs of letters compared are giving true, then combined is still true. So if we run it now, we have twice that the array is not a palindrome. For that case I had, and if I do it in this way, they should both be a palindrome. And just to close it, I gave an example just on a numeric array, but it would have worked perfectly fine if you insert a text array. For instance, the most common palindrome to be given as an example is radar. So that one also is a palindrome, and it works without editing anything else in the code, because this is also an array, and in our code we basically compare array elements in here and also in here. So comparison is radar equal, I'll type something else. So in here I would get 0, 1, 1, 1, 0. So as long as we have, oh sorry, I compared, yeah, it's actually 1, 1, 1, 0. So I meant to show that if I have radar and or non-palindrome like this one, and then the flipped one. Yeah, then it's 0, 1, 1, 1, 0. So again, since they are arrays, it doesn't matter they are character arrays. MATLAB compares those characters and then says true, false for each pair. So in this way, this code could be working for any kind of array. And if you want to let the user decide what they want to check to be a palindrome, instead of defining these fixed yourself, you just use input. And notice now that I'm setting what the input will take in. I'm assigning again to variable x because that's the one which is then being used throughout the code for the checking. Give any array, and to avoid any complications, whether they insert a number or a string array and so on, I will ask MATLAB to treat every input as a string. So I'm making sure that there is no unnecessary errors in my code just because somebody entered a number, for instance. So in this case, when I run, MATLAB jumps into command window, asks me for that array, and I will give, let's say, some number which is a palindrome. So this one is symmetric, and even though it's a kind of from the keyboard it was typed in as a number, it is immediately translated into a string array, so it then is just like as if it was a word. So let's press enter here, and you can see here now in the workspace x is actually a string array because it has those small quotes around it, so it means it's not a number for MATLAB anymore in this case. But it is a palindrome because it is symmetric, so both the methods work correctly.